Let's take a look at another problem. Find the distance between the 2 points 1, 0 and 6, 8. So here we're going to use a right triangle once again and use Pythagorean theorem. But what we discussed in class was, what if graph paper isn't readily available? How do I still find the side lengths of the legs A and B so that I can eventually solve for the hypotenuse C? Well, we figured out that we could just use the coordinates from the original points. That if I first think horizontally, if I start here and work my way to the right, that what helps me figure that out is the x-coordinate. The x-coordinates control horizontal movement. So if I think horizontally, 1 and 6 are my start and end points. So I went from 1 to 6, or another way to calculate distance would be 6, where I ended up, minus 1, where I started from, which gives me a distance of 5. Now what we also discussed in class is that we could then find the other side of the triangle by thinking vertically. If I think about where I started from vertically and where I ended up, that it's the y-coordinates that controlled that movement. I started at 0 and went to 8, or another way to calculate it is 8 minus 0, which equals a distance of 8. So now I've got a way to calculate sides A and B without actually needing graph paper. Alright, so let's take a look at what we've been discussing and look at it in a more general way. First, let's assume no graph paper. And instead of specific points, let's use the coordinates x sub 1 and y sub 1 to denote the first point, and x sub 2, y sub 2 to denote the second point. So what we figured out is that if we find the horizontal and the vertical distances between these 2 points, those are the same thing as sides A and B, the legs of our right triangle. So let's look at the horizontal first. If I look at where I started from and where I ended up, what controls that movement are the x-coordinates. And so then what I can realize is that, well, if I started at x sub 1 and ended up at x sub 2, that to find the distance between them, A would just be x sub 2 minus x sub 1. And then I can use the same approach vertically. If I think where I started from and where I ended up, what controls that movement is the y-coordinates. And to find B, it's y sub 2 minus y sub 1. And so this is a way we can find sides A and B of our right triangle in any given situation. A is x sub 2 minus x sub 1, and B is y sub 2 minus y sub 1. Alright, let's take a look at what we've got so far. First, to find the distance between 2 points, we view it as a right triangle. We realize that the hypotenuse, C, will actually turn out to be the distance, and that A can be rewritten as x sub 2 minus x sub 1, and B can be rewritten as y sub 2 minus y sub 1. So let's take what we've got so far and go a little bit further. So the next thing we can do is realize that A can be re-represented as x2 minus x1, and B can be represented as y2 minus y1. So if we put those in, we get this formula. Now the last thing is, of course, we're solving for distance on the right-hand side there, but not distance squared. And so eventually, somewhere in this process, we're going to square root both sides of the equation. In fact, what we're going to do is we're going to do that now. And on the right side of the equation, what will happen is the square and the square root will cancel, and we'll just get distance. And so what you see on the left is what's called the distance formula. The square root of, parentheses, x2 minus x1 squared, plus parentheses, y2 minus y1 squared, whatever that turns out to be, that will be the distance between our 2 original points.